Hi guys. Today I'm coming to you from my mom's house. Our washing machine is broken and I'm here doing laundry. Yay! Today we're technically starting a new unit. This new unit is going to be atomic structure and naming compounds. That's what we'll do this week and next week. Maybe into the following week. It's kind of important, this naming stuff, but atomic structure. Here we go. Okay, so the first thing, atoms. The fancy chemistry definition of an atom is the smallest particle of an element that still has the characteristics of that element. Always define an atom as like an M&M. Technically, if you take off the shell, it's not an M&M. If the characteristics of an M&M is it has a candy shell, it's chocolate in the middle, and there's an M, that's an M&M atom. If you take any one of those away, technically it's not an M&M. You know, have you ever bought those trail mixes that have things that look like M&Ms, but there's not M's on them, so they don't taste the same? Yeah, not an M&M. That's what it means by characteristics. Here's some pictures that, and it's made of 3 basic subatomic particles. So pictures of things you may have seen of atoms. There are way more than just 3 subatomic particles, but that's all theoretical physics, and we are not going to worry about it. So a subatomic particle is what is inside an atom. So here, this is what they are. They are protons, neutrons, and electrons. Sometimes these are the like symbol abbreviations. I will pretty much always do P plus and 0 E minus. So the plus, 0, and minus, that's its charge. So the charge of a proton is 1 plus. Neutron, neutral, no charge, 0, that would be a 0. Electrons are a -1. Where are they located? Protons are located in the nucleus. Protons and neutrons are in the nucleus. Electrons are in shells outside the nucleus. We're going to do more of that tomorrow. What is the mass? This is more about the nucleus. So the nucleus is the small, dense center of the atom. How small is it? Like if you went to Arrowhead Stadium and took a teeny tiny itty bitty marble and set it in the 50-yard line, that would be the nucleus, and the rest of the stadium would be the electron shells, or sometimes called clouds. It contains almost all of the mass of an atom. So that teeny tiny marble in the middle of a stadium is all of the mass of an atom. What does it contain? Protons and neutrons, as you saw in the beginning. Lots of times those are viewed like that. Again, another picture, protons and neutrons, the electrons surrounding. This is kind of more what it is, protons and neutrons, and this electrons is in like this circle-y shell. We'll talk more about this tomorrow. Again, another picture, electrons high speed, protons and neutrons. Okay, what are their jobs? This is the most important thing. That's a lie. The mass. So if all the mass is in the nucleus, that means protons and neutrons weigh 1 AMU. We talked about that with the mole worksheet, but an AMU is called an atomic mass unit. It's just a metric unit for small objects. Essentially, it's the mass of a proton and a neutron, but they just use it to measure the mass of a single atom. And electrons are 2,000 times smaller. So, that's why the nucleus makes up most of the mass, because here's your mass, and then 2,000 times smaller. It doesn't really matter. The job, okay, here's the job one, the most important part about a job. The protons determine the identity of an element. Neutrons are what help hold the nucleus together. And then the electrons, again, is determined bonding. It determines how things react. Again, we're going to talk more about electrons tomorrow. Bonding is going to be, that's what the naming is. So that's kind of why we're talking about it. We'll do number in a second. So how do you know how many protons and neutrons and electrons are in an atom? You look at the periodic table. So here's one of those squares. I just picked lithium. So the top number is called the atomic number. Atomic number is always going to be the whole number. It's always your number of protons. That thing that does not vary in an element, it is the same in all atoms of that element. That's why it determines the identity. If you have 3 protons, you're lithium. If you have 4 protons, you're boron. If you have 5, you're nitrogen, I think. I don't have a periodic table in front of me. So you get it, right? Atomic mass. Why is it a decimal? Because it's a number of protons plus a number of neutrons. It is called a weighted average of all isotopes. If you have just one atom, it'll be a whole number. An isotope is literally, we're going to talk about the next slide, but it's a weighted average because, as we know, not every atom weighs the same, and even every atom of an element does not weigh the same. Okay, so what is an isotope? Isotope is the not so science definition is different forms of the same element. Why? Is it the same element? Well, the only thing that an isotope is the same element with different number of neutrons. Why is it an isotope? Because iso means the same. All isotopes are going to have this. They're going to have different atomic masses, but the atomic number is going to be the same. So some are stable, some are radioactive. So carbon-12 and carbon-14. So here's a picture. So again, these are isotopes. You notice the name is the same. Protons are the identity. There's 6 protons here, 6 protons here. So carbon-12, that's why it's carbon. 6 and 6 protons. The difference is the neutrons. There's more neutrons here. Okay, so symbols. This is one of the ways you'll see symbols. Those whole numbers there are called mass numbers. Why is it mass number and not atomic mass? Because it's a whole number. It is only protons plus neutrons. So how do you know how many protons, neutrons, and electrons? Well, atomic number is number of protons. Atomic mass is going to be, it just says protons plus neutrons. So carbon, how many protons does it have? 6. So in this one, it has 6 protons. The mass number is 14, and 6 is here. So 6 minus 14 is 8. And electrons in all atoms are the same as protons. So that's going to be 6. With carbon-12, so protons is going to be the same. The only difference is neutrons. Actually, protons and electrons are going to be the same. 6 and 6. This one now has 12 minus 6 is 6. So, 6, 6, 6. Funny. Carbon is in everything. 6 protons, 6 neutrons, and 6 electrons. Okay, there you go. So again, last super duper important bullet. All atoms have the same number of protons and electrons. Atoms. We're going to do... ions tomorrow. Okay, so the last thing, how do you know number? Atomic number. Neutrons is mass minus atomic number. And then electrons is same as protons for now. So a couple practice with this. Symbol information. So if you ever just see a symbol with numbers around it. So the middle thing is always going to be your element symbol. I picked carbon, but it could be any element. Up here is the atomic mass, protons plus neutrons. Down here is going to be atomic number, which is always just protons. And up here, when we get to it, would be a charge, but right now, 0 charge is an atom, so there's not going to be anything there. So there you go. I hope I'm not going too fast. Protons plus neutrons, just protons, and then for now, there's not going to be anything there. So here's the periodic table, so I can flip back to it. Okay, so practice counting protons, neutrons, and electrons. So first off, so this one throws it all up because I have an animation for it. But okay, so always the bottom number is going to be your protons. How do you find neutrons? You just subtract them. So it's wonderful that they line them up like that, so you can do subtraction by hand if you have to. An electron is the same as protons. Okay, so then iron, there's nothing there, so that's why it's the same. Okay, so this one I'm pretty sure I have to write things in. So FYI, when you do your homework, pick a light color because it's all going to be on this background. So protons is the same as this bottom number, so iron is 26. Neutrons, if you do 54 minus 26, is 14 minus 6. It's 28. Is it 28? I hope it's 28. And then electrons is the same as protons, so that's now 26. That's it. That's all you do. You subtract them for neutrons, and protons and electrons are going to be the same. So that's easy. If you have a chart like this, so here we go. This is the easy part. So symbol, you just look at a periodic table and you put the symbols in. Atomic number is the same as protons and for now electrons. So you just take that number and you put it in protons and electrons. Atomic number is, again, protons, so 12, and electrons, 12. Yay! Now, number of neutrons is, ready? I kind of threw them in this, well, it's flipped, but it's in this order because, well, really neutrons, whatever. It's in this order, so mass minus atomic number is neutrons, or mass minus protons is neutrons. That's really what it is. So this one has 2, helium has 2. So now, how do you figure out the mass? Well, you go back through. Protons plus neutrons is the mass. So 12 plus 12 is 24. And that's part of what, you'll do that on the homework too. You just fill in the numbers. Okay, and then the last practice is if I give you protons, neutrons, and electrons, we're going to draw the symbol like, you know, with the 3 things. So first off, oh, I should have put the periodic table right before here. Oops. Okay, so first thing is to figure out what the symbol is. How do you do that? You look at the protons. So 9 protons is fluorine. So I'm going to put an F. And you might as well put the 9 down here. Electrons is the same, so there's nothing here. If you want to put a 0, I guess you can, but you don't have to. Now, mass number is protons plus neutrons, so G, that's 19. That's all you got to do for these. The next one is protons 18. Well, okay, protons are 18. So what element is that? 18. Argon. So you go, you put AR. You do 18 down here because that's protons, and 18 plus 22 is 4D. That's it. That's all you're going to do. You're just going to have practice problems literally doing all 3 of these. The first one is you'll do this for the first question. You fill in the rest. I have like 6 more for the chart, and then there'll be like 1 of these. So that's what your homework's going to be. Oh, there you go. That's one of them. So hopefully this is okay and not too fast. It's pretty easy. If you need to go back and watch the video again, do it. That's the beauty of this. So we'll talk to you guys tomorrow.